afternoon, everybody. My name is Pavel Hübner. I'm a CTO and co-founder of HARDWARIO. And today I will be presenting our initiative, which is called Open Source LoRaWAN Firmware for Murata Module. And there is actually a leader of this initiative, Jan Janák, the researcher from the University of Columbia, who cannot be here with us, so he greets you all. But we are working on this together, so you will hear many of his ideas. So in HARDWARIO, we do hardware, we do connected stuff. And let me give you a bit of a story why we are doing this initiative. So we started doing platforms, IoT platforms that are connected and they are modular on hardware and software level. And this is one of them. This is called Tower. It's a pluggable IoT platform that is focused on IoT projects, on low-power sensors. And originally, it was intended for educators, makers. But we found out that it's actually very useful for industrial use cases. But we felt something is not right. And for the industrial use cases, you need a little different approach, more robust casing, enclosures. You need different types of interfaces. So we have created a platform called Chester. And you can see, you could have seen it on a previous slide, in the circle, we have implemented LoRaWAN module from Murata, type ABZ, still very popular today. Actually, if you go to Murata, it is like the recommended LoRa module, despite they have the newer models. And we like it. It has solid hardware, good performing RF radio, it is programmable. So we took all the good stuff we had in Tower, this IoT kit, and we have created a platform called Chester, the IoT configurable gateway, which implements, again, here you can see in the circle, the same module. And this gateway offers a lot of other features like Bluetooth, lots of industrial connectivity, precision analog, digital inputs, analog inputs, RS485, you name it. And we are doing lots of applications. We are targeting lots of verticals with it. And we are approached by lots of companies around the world. And there was one project from Australia. And this is where we used Chester. And what happened? The customer asked for application to monitor industrial or street lighting. They wanted to measure energy consumption. And they had their own LoRaWAN network in the city of Canning. And the LoRaWAN network was connected to Things Industries. That was my first experience with this technology. And everything looked good. We have developed the product in the Czech Republic. Everything was on the table perfect. And we shipped the units to Australia. They started connecting to network. And it failed. We had terrible problems. And we were debugging this remotely. It was a combination of the settings on the LoRaWAN modem side, on the gateway side. We were trying to tweak various configurations. And it was a repeating process. We were waking up very early in the mornings because of the time zones. And you know, Australians, they like barbecue, they like parties. You cannot delay the network until night. So it was a lot of early mornings, which were difficult for us to debug that problem. The core of the problem was that there was an incompatibility with channel masks. And those of you who implement LoRaWAN devices, you know what I'm talking about. It's a mechanism just to lock to specific bands. It's controlled by, it's a combination of device talk between gateway and LoRaWAN server. And the problem was with this original Murata firmware, there was simply incompatibility. And we couldn't do something about it, but there was one option. We decided that we will implement our own firmware. And we wanted to solve that particular problem because we were behind the schedule and customer really wanted it. So we started this initiative and we have solved the thing. This was the first proof of concept implementation. By that time, it was closed source, but the long-term vision was to open it. But as it is, we have a lot of projects in the company, and we didn't have like internal resources to really take it onward and to make it in a fulfill the vision that we should support all the commands over 80 command interface. So the project was on hold until Jan, the guy from the first slide, appeared on the scene, and he he said that he will help us to finish and fulfill this vision. So we defined the objectives, and the goal was to develop high-quality open-source firmware for LoRaWAN that everybody can use. You see this Murata type ABZ, it's very popular, and there is quite a lot of hardware implementations around it. We wanted, of course, to have the implementation on GitHub. The goal was to support the latest LoRaWAN stack versions, and also to be fully compatible with the current Murata implementation. So something about the Murata module itself. So it's a module which encapsulates MCU from ST Microelectronics, Semtech SX1276, of course the temperature-compensated crystal, the RF filter balloon and stuff like that. So it's really easy to integrate. You just connect VDD, you connect the serial port, and it's a AT command level interface. There are some other implementations. I'm not aware of all of these, but we are now talking about this OpenMCU approach. And we are basically leaving the original Murata vendor firmware aside. And the reason, as I said, was we wanted to be more up-to-date with what Semtech's open source stack is offering. So the main features of this implementation should be to support all LoRaWAN regions, support the latest stack version. Also, there is ongoing support for LoRa Class B, so you can have low-power LoRa sleeping devices which are able to receive packets. And we have also done some efforts to really improve the original Semtech stack. Jan has done a great job. He's extensively testing this with students on his real projects. And he has done some major contribution, which was accepted by Semtech. So we are really supporting the latest additions with some custom patches. And we will keep continuing improving the LoRa Mac node repository. And of course, it would be useless, all this initiative, if it didn't come with proper documentation for all the AT commands, and if it didn't provide the seamless way for the users to switch over from the original vendor firmware to this new one. I will go back to the previous slide. I forgot to mention there is a picture. This is an example where Murata module is implemented in Arduino board, MKR1. So we are already having some users. We are tracking down if one of the users is actually from Arduino organization, but this is like one of the areas that we want to approach, to get more people on the board, to start testing it, get bigger exposure, and have this open firmware. So this is the architecture. First, we need some AT command interface layer. And you may be thinking, AT commands, things of the past, no way. If you have some device that has UART, it's absolutely fine. Today, you have a lot of options. For example, STM32WL. You can create the whole application. And for sensor applications, if you start new projects, it's the natural way how you want to start. Still, if you are doing that modular hardware, those modular systems, it makes a lot of sense to actually pick a modem-based solutions with AT commands. Despite it has been invented 50 years ago or something like that, it still will have a place, I believe, in the next decades to go. So AT command interface is the first layer. Then we need some state management for the data, for the flash memory data. Of course, we are using STM32 HAL driver libraries. And we are obviously implementing that LoRa Mac node, that GitHub repository being maintained by Semtech company. Also, we went further. We wanted to have some modem management tool that will make your life easier. So you will be able to configure the modem. And Jan has created this Python tool called LoRa Modem ABZ that is available from Python package index. And you can use this tool to simply grab some information, get basic information about the modem, about the current status of the network. And through the CLI, you can also do this analysis of the current network state. So you can see what is the current data rate, what are the frequency channels, stuff like that, or signal strength. and all this stuff that will be really handy if you are in the field and you want to know and debug what's the connection state. It supports several other commands, as you can see. It's not definitely a part of the scope of this talk to go in each of them, don't worry. But it's just to give you information that such things exist, and if you ever come across this LoRa Murata thing, you will have this tooling available. Also, it's not available just from the command line. There is a high-level Python API, so you can import the module and work with it in a programmatic way. And there are some other things in the roadmap, and my colleague Jan, he doesn't have to be told what to do with it next. It's beautiful because this is a good example how academia and real life meets together, and it just shows that that this collaboration between the university and industry can work in an awesome way. So the next phase is to implement time synchronization in the LoRaWAN network. Also firmware updates, and as I mentioned, Class B mode of operation for the devices, so we can have it in low power mode for reception. And some other stuff, like this IPv6 addressing. This is really advanced stuff, but as I said, we need to have some part of the research to keep people in academia motivated participating in this. And in a summary, I would like to say, this is the new thing. If you know somebody who is implementing this Murata module, let them know. It doesn't have to be the whole implementation related only to Murata. It, of course, because it's a combination of ST Micro and Semtech chip, it can be easily ported also to some other solutions. Also, I would say that this implementation is a nice example how to actually use LoRa Mac node repository from Semtech, because despite this repository is receiving a lot of attention, unfortunately, you will not find too many open implementations, too many examples utilizing this implementation. It's documented. If you go to this repository, github.com/hardwario/LoRa Modem ABZ, there is a wiki link. So if you click on it, you will see the really comprehensive set of documentation. I would say the documentation is actually way more comprehensive than the original one. And we will be happy to hear your feedback, share your thoughts, tell your friends if anybody is using it. And this is something that is now keeping pace up with the latest Semtech developments. So that is it, LoRa Murata ABZ modem firmware, and thank you for this attention.
I'm all you need. You're a drunk, you're a fool. I'm insane, so right.